Welcome everyone. My name is Anis Moumen from National School of Applied Sciences of Kenitra, Ibn Tufayl University. Before starting my presentation, I want to thank all the organizers of the 6th edition of the International Conference on Wireless Technologies and Embedded and Intelligent System for this opportunity and for all their efforts. My presentation today is about big data architecture for Moroccan water stakeholders, proposal and perception. It will be organized into four sections and the conclusion. In first, I will make a brief introduction to big data concept, characteristics, and architecture. Next, I will move to present the literature review about big data architecture for water resources. And before presenting our empirical study, I will present a big data architecture proposal for Moroccan water stakeholders. The word big data probably appeared from the 1990s, used for the first time in 1989 by the American journalist and the author of non-fiction books, Eric Larson, to describe the problem he was dealing with. Receiving massive emails. Big data didn't appear for the first time into computer science references, but it seems that would be used by the economist Francis Diablot from Pennsylvania University on 2003 into his article titled Big Data Dynamic Factor Models for Macroeconomic Measurement and Forecasting. Also, the big data as an idea was popularized from the 2000s by John Mackay in a computer vision context with increasing of digital content produced by nowadays users. We can conclude that big data as a concept was introduced by non-informatics and used to describe the massive production of unstructured data, which probably contain an important economic value for the organizations. Also, big data environment was born because of the limitation of the classical environments, which didn't to capture, process, analysis, and storage huge data in an acceptable time. So big data established a new paradigm to deal with massive data and redefine the IT architecture, which will upset the IT usage of the organizations. According to Doug Laney, big data can be described by the following characteristics: volume, variety, velocity, veracity, value, and variability. Volume it refers to the quantity of data generated and generated and stored data. Variety, it's about the multiple type and nature of the data. Velocity, it's about the speed at which the data is generated and processed. Veracity, it refers to the data quality and the data value, and specifically to the metadata. Value, it refers to the utility that can be extracted from the data. Variability, it refers to the data whose value or other characteristic are shifting in relation to the context in which they are being generated. Other important characteristic of big data was introduced by the progress of the literature and works, scientific works. For example, exhaustive, fine-grained, and uniquely lexical relational extensional scalability. According to Cravello and all, who published in 2018 a paper about big data architecture for water resources management, a systematic mapping study, big data architecture refers to the logical and physical structure that dictates how high volume of data are ingested, processed, stored, managed, and accessed. This architecture is built by through the layers, 4 layers: big data sources layer, management and storage layer, analysis layer, and presentation layer. Meteorology was the first scientific discipline to use and produce big data. For example, the NASA Center for Climate Simulation, debuting in spring 2010, stores 32 petabytes of climate observations and simulations on the Discover supercomputing cluster. In Morocco, the climate observation is conducted by several public actors as the Royal Center for Space Remote Sensing, which is the official distributor of the satellite images in Morocco. Concerning water resources, the sector is characterized by an important number of actors, which can be classed into 2 categories, central actors and regional actors. Now I will move to present an overview of our systematic literature review published in 2020 by presenting some applications and scientific works like from Yinghui Zhao and all that propose and implement a big data analytics architecture for water resources sustainability evaluation in the city of Zhoushan. This architecture is built with 4 layers: hardware layer, communication layer, middleware layer, application layer. This architecture takes into consideration multiple formats of sources, IoT, internet database, and files. Mo, Zhang, and all propose an architecture based on IoT for water resources monitoring and management. The authors build this architecture around 3 layers: equipment perception layer, information transmission layer, and data application layer. For this proposal, the authors take into consideration IoT only as an input, because the use case is to monitor and manage water resources. For Moroccan authors, Ridwan Shlah and all propose a big data architecture for water management, water resources management. It seems that the authors have made an implementation of the support decision model for Moroccan water resources. To propose a big data architecture for Moroccan water stakeholders, we are inspired from state-of-art presented in previous slides. Our architecture is structured into 5 layers. The figure beside summarizes the different components from data sources layer, data storage layer, data acquisition layer, and data processing layer, and finally a presentation layer for different use cases. The input of our architecture take into consideration files, databases, GIS, maps, station measurement, and reports. Concerning the use cases proposed for this architecture, they are to deal with the national issues like pollution, natural water quality, natural risk like flood forecasting, and water prediction and modeling. The approach to design a big data architecture for water stakeholders started by an area observation to appreciate both the real object and its components: rivers, wells, stations, dams, etc. Also, we analyze the opinions of decision makers, reports, and measurement sheets. This approach was conducted to observe the water entities and their attributes, and also to identify the opinion of the decision makers of water stakeholders in our city area. So our city area is the Girziz Riz in the southeast of Morocco, limited to southeast of Morocco, limited to the north by Middleware Basin, by the Dar'a Basin in northeast, and by the Algerian border in the south. In this area, a lot of actors are concerned by water resources management, like Water Basin Agency, WINE, Lonzua, and in addition to the ONGs and academics. The first result of the continent analysis of reports and measurement sheets, accompanied by in-depth interviews, allowed us to draw up a list of data on water resources that are mostly taken into consideration by decision makers. We have noticed the diversity of both entities and attributes. So, according to this analysis, water data can be divided into three categories: groundwater, surface water, and climate data. For example, climate data is measured by their attributes: temperature, evaporation, wind, rainfall, and humidity. The interviews allowed us to identify the word cloud, which shows an important occurrence of the words data, ECT, citizens, time, services. We can conclude that the main motivation on the use of ICT by the public administration in Morocco is to improve citizens' services, in particular their responsiveness. Also, the continent analysis of stakeholders' opinions about the perception and constraints about adoption of big data architecture can be summarized as below. First, the concept of big data is quite clear for our interviewees. Second, the use of big data may not use it soon, but rather in the near future. Third, the motivation for use of big data is to improve the user's services. The users is divided into three categories: internal collaborators, external partners, and citizens. The constraints for the use of big data are legislative, organizational, technical, and human. According to this analysis, continent analysis, data confidentiality and security are important requirements for the use of big data. Staff training action should focus on training courses to raise users' awareness, technical training for monitoring and maintenance of hardware and software platform, technical training for analysis by using BI tools and data mining into big data architecture. I have now come to the end of my presentation. In summary, I spoke about a proposed approach to design big data architecture for water resources in Morocco, from literature review and also from reports, interviews with experts and observations with Moroccan stakeholders, to characterize water entities and to summarize all comments about the use of big data technologies. Thank you for your attention, and I will be happy to answer any question in our conference.